The grand finale here of this slide deck. Welcome back. The final 3 slides of this slide deck now think about monetary policy trade-offs. And it's yet one additional piece of analysis that this paper does, which is asking, what can the central bank do? So we saw in the previous lecture that the central bank responding to R star is affecting allocations quite substantially. Now they also ask, is there another strategy that the central bank could consider? And would that affect the allocations in a noticeable way? And here they are experimenting with a parameter. In particular, they are experimenting with the reaction coefficient on the output gap. And they explore different parameter values. So they vary a parameter between 0 and 1. And they study the properties of their model. So first of all, where does this parameter show up? Well, it's showing up here in the Taylor group. Right? So it's the aggressiveness by which the central bank responds to output gap changes. So typically, when actual output exceeds potential output, so you have a positive output gap, then they're going to raise the normal interest rate to cool the economy, right? They want output to be at potential at best, to have a 0 output gap. And if that output gap is positive, this parameter, of course, is crucial by how much the normal interest rate is moved around. And what they do now is they are considering different values of phi and ask, what does this do to the record of the central bank in terms of interest rates and inflation and GDP and so forth. Okay. That's what they do. So now this model has shocks, cyclical shocks, right? This model has these 4 shocks, right? So there's these 4: there's the demand shock, monetary policy shock, the cost push shock, and the emissions shock. So there's these business cycle shocks. But then there's also these climate factors. These are more structural factors, right? So these are the trends. And the central bank needs to somehow take both of them into account in this analysis. If it is overly hawkish, yeah, it will stabilize the business cycle, but it will have lots of volatility in R, which is going to feed back to inflation and others. All right, so that's what they also looked at. So then they do something that requires a little bit of an explanation. And let's start with what they do here. Okay. So you can think about these graphs you can think about as indifference curves, or volatility frontier is a better word for it. It's a volatility frontier. So these are volatility frontiers. Okay, so maybe you're going to annotate this as volatility frontier. So on the x-axis, we have the volatility of detrended output. Okay, so this is E of 100 times y squared. Okay, so this is the volatility of detrended output. So this is the volatility of output. Okay. And on the y-axis, we have the volatility of inflation. Okay, so this is the volatility of inflation. Now, suppose you're running the central bank of Vietnam at some point in the future. In this graph, what point would you pick and define as your personal bliss point? Where you're saying, this is the perfect. I mean, if I could, I would pick this point in this graph. What would you pick? Which point? I mean, there's like tons of points in this graph, right? I mean, you have lots of points here. Lots of points there, and all the deviation items.
Inverse kind of utility logic. So for a utility in different curve, you want to pick the one that is outer the most.
That's outer the most.
You want to pick the one that is inner the most.
Exactly. Okay, so picking out or picking in. So now we have to decide which one is the bliss point or which is the best point here. Like, suppose we have a point that's out here. What is this doing? Right? This is going to give us 14% volatility in variance in inflation and an output and a positive variance in inflation. So we're going to be up here. This is an economy that has lots of volatility. Is this going to be a bliss point? In other words, do you like as a central banker to have inflation doing like this and to have output doing like this? Do we like that? Why not? We hate volatility, right? So which point would you choose if you can?
Closer
To the origin,
yeah.
right? So the bliss is down here, right? So it's not, the bliss is the 0, 0. That's the bliss. So that would be the bliss point in the sense of you would actually have 0 volatility in inflation and 0 volatility in output. That's the idea, right? Output would keep on steadily growing. Inflation would always be 0 or at target 2% and it would never fluctuate. That's from the central banker's perspective, the bliss point. So if you go out, this is actually, we use a different color. I'm going to use red because we have red lines in here. We want, so this is bad or worse. Okay, so the further you go out, the worse it is. All right, now we understand that. Now let's go and let's make sense of what these curved lines are. The red is it's a little bad name, so it's business as usual. Let's replace that by laissez-faire. Okay, so this is called laissez-faire, right? That's the same, laissez-faire that we have, in all the other lines. That's the idea. So that is laissez-faire. How do you spell that? My French is laissez-faire. Let's see. I have to brush up my I have to brush up my French. No, it's E. It is an E there. That's French. Laissez-faire. So it's laissez-faire is French for let it go. Let it like evolve as is. No interventions. Hands off. It goes back to famous French economists and also philosophers. Hands off. Got no government. Just keep the economy going as is. That's where the laissez-faire comes from. All right. Good. So now, what are these points now? What are these? Each of these points is a particular value for phi y. So phi y, right, is between 0 and 1. Okay? And what the authors do is they pick a parameter. Suppose they pick phi equal to 0. They set this equal to 0. Then, the central bank doesn't try to stabilize output variability. If this is 0, this disappears, and the central bank doesn't care about the volatility of the output gap in its reaction function. So that's the point in this kind of graph down here. This is the point for phi y equal to 0. So this is phi y equal to 0. Because at that point, you're going to get some volatility in output. Okay? The output is going to be some volatility because you don't care about the volatility of output. But implicitly, you're going to get less volatility of inflation because, in your reaction function, you do react to inflation variations. So the name of the game here is, right, this is whatever it is. When there's inflation higher or lower than target, the central bank is going to move its interest rate, but it's going to disregard this. So you get some volatility of output and less volatility of inflation. And then as you go along each of these dots, that is phi y approximately equal to 1. So this is now a point in this volatility frontier when you're penalizing output variations in your Taylor rule. So if output goes up, you're going to try to counteract it, so you're going to stabilize output, and that means you're going to have less volatility in output. You're going to move this way, but this comes at a cost. You're going to have more volatility in inflation. That's how you have to read this part. So the central bank has this volatility frontier, and it can choose a point on this volatility frontier. That's the basic bottom line. By choosing a reaction coefficient. Okay? So that's the volatility frontier that you have. And now there is a force between the cyclical forces and the structural forces in this economy. And it goes like this. Notice that in this volatility frontier, right, this is the volatility of the model variables in the first 25 years of the transition. So the authors consider a transition, and then they consider different phi values, and always compute what's the volatility of output and inflation in the first 25 years. So that's like, in terms of the time domain, they always look at, you know, what is the volatility in the first 25 years, from 2023 to 2020, 2050, roughly like that. First to 2028, 2048, that's what it is. And they compute the volatility here. And then they compute the volatility in the later sample. So that's what they do. So what you will first notice is that the green is now the Paris Agreement. Okay, that's when this, you know, when we have these carbon taxes. And what these carbon taxes produce is they produce a more, you know, an inferior volatility frontier. The carbon taxes are bad; they increase the volatility, and we've seen this so many times. We've seen that consumption goes down a lot, right? The green consumption dynamics. Let's take a look at that, which is this. Notice how much more volatile consumption is here, right, relative to the red line. So these taxes, these carbon taxes, the mitigation, the central bank responses, they are making this economy more volatile. That's the first bottom line. And, you know, something to understand that there, you know, these volatility frontiers are such that, you know, the Paris Agreement volatility frontier is out there relative to the laissez-faire. So from a volatility frontier perspective, you know, this one is strictly superior to this one. All these points are worse than all these points. So that's the first thing to notice. And then the central bank can pick, you know, its point for phi here as well. But now comes the kicker. When you look at the volatility frontier for the remaining 50 years, so for the longer run, notice what happens. You're going to get a switch in the ordering of the volatility frontier. Right? Notice here, this is laissez-faire, is superior to Paris, but then later on, you're going to get a switch. Now, in those 50 years, you see that the economy with the carbon emissions being reduced to zero has a better volatility frontier than the laissez-faire. That's the key here. And so why can we make sense, or how can we make sense of this? Why would this actually be the case? Well, notice that in the later sample, the laissez-faire economy is an economy where output has deteriorated a lot because of structural forces. Right? There are structural forces that has hit the laissez-faire economy that has led to allocations that are lower in the level, and the economy is more strained. So if you have shocks hitting in those 50 years, they affect the economy to a greater extent. So long story short, these structural forces lead to it basically makes shocks more adverse, if you like. That's one way to think about that. So there's the greenflation investment boom, so to say, drives this volatility frontier down, but the climate-inflation effects on the laissez-faire economy drive the frontier here out. So that's basically the idea. So we have this very interesting and intriguing result that, right, so this just plots in this line here. You see this outward shift of the volatility frontier for the laissez-faire. So again, that illustrates again this short-term pain, long-term gain type of idea. There's this short-term, pain and long-term yields or gains coming from, climate policies in this type of model. Now, you have to have a long horizon, right? This after 25 years. So this is in the year 2050. I will be dead by then, most likely. But the idea is that you know, there's a long horizon that you need to have for this to become effective and coming important. But it's an important dimension to keep in mind that, you know, the volatility is affected also in an adverse way by not acting. Go ahead.
Because we see that the reserve place in 15 years later, it will shift to the right.
Yeah.
So can we say that it's sooner is better if we do the Paris Agreement?
So I see. I don't know the answer to your question. That is speculation. So I think what one need to do. So this is where the Paris Agreement and the laissez-faire, right, as we discussed it. I think an interesting exercise that could be done is to go back to these extensions that we discussed and implement this optimal transition. You know, going to Paris faster, and then compute again these volatility frontiers. I think that would be an interesting question. I think, Linda, is that at the core of your question? In thinking about if we go faster, can we get that? Can we, you know, that, right? So, no, maybe we go back here. The laissez-faire, Lynn, the laissez-faire shift happens irrespective of Paris. That because, you know, laissez-faire means there is no carbon tax. So that shift is going to be always there. It's not going to be affecting. It's not going to come sooner or later. The question is, how much does this thing move relative to red with the optimal choice? And then you see there is a little bit. You know, this one shifts a little in, right? So let's see. This last dot here is at 0.4 and 14. 0.4 and 14. You see the green shifts in and the red shifts out. So the green shifts in and the red shifts out. Okay, so here they only plotted the red out shift, but the green, maybe we can have another color in here. So maybe we can have another color here. So the green actually shifts in. Okay. That's why they didn't draw it, because it's very hard to read. But the green, you know, shifts in and the red shifts out. And then is the question, you know, can we get this inward shift that's policy induced, that's induced by fiscal or climate policy? Can we get that inward shift faster? Not only by 2050 and beyond, but faster. And so could we have that inward shift happening in a quicker point in time? And then I think an interesting exercise could be to consider the optimal transition, you know, that would be well for maximizing, and consider when you are on an optimal transition, how quickly is that inward shift going to happen? Yeah. So it's I think it's very interesting in so many ways to consider and play with this. So again, this is laissez-faire. All right. So the central bank, you know, the trade-off by the central bank gets, so to say, less severe by climate policy. That's another way to think about that. Climate policy, so that is carbon taxes, they are improving the trade-off for the central bank. In the medium term, they make it worse in the short run. So climate policy makes the trade-off worse in the short run. So Isabel Schnabel, Christine Lagarde, Jay Powell, they hate it here, but they love it there. That's how we have to think about this. Okay. So climate policy, that's the big bottom line, makes central banking trade-offs harder in the short run, but easier in the long run. So why don't we write that down? Okay. So climate policy deteriorates the trade-off in the short run, but improves it in the long run. Yeah. Perfect. Okay, trade-off in the short run, but improves it in the long run. That's the basic one. Wonderful. Are there any questions? There are no questions. It's time to wrap up and basically take a stand on what does this paper do? What did we learn from this paper? I mean, we've been now busy for Wednesday, Thursday, Friday, Monday, and half of Tuesday. It's about 4.5 days of work. Good 4 days of work. So we put in a lot of work and effort and understanding this, right? So what did we learn from this paper? I mean, I told you that in this course we want to understand where is the research frontier and what does it teach us? What, in fact, did it help us think about the topic of macro climate? And so first we learned what are the steps to do a minimal change to the New Keynesian model to talk sensibly about climate change in the New Keynesian model, right? And that's the first accomplishment that this paper has offered us. I mean, in case you've never thought about climate change, this paper allows you to think about in a rigorous way, in a structured way, about the effects of climate change. And we learn how to do that, technicalities and the assumptions surrounding it. And then it also allows us to think about the two objects that central bankers are talking about a lot, namely climateflation and greenflation effects. And we're able to quantify it now. We understand how the model was taken to the data, the quantitative analysis, and we learned that these are quantitatively important effects. This is not like a 1.1% higher inflation because of climate change. No, it could be substantial, about 1% or maybe 2-3%. Right? So these are substantial numbers. And what they do is that we're thinking about how monetary policy can affect, so to say, these types of transitions, and that was to a large part what we did today, at least in the last hour. We also learned that there's a structural change, and targeting our star could be beneficial, and there's a short-term pain and long-term gain from mitigation policies, even for central bankers. And the effects that they have isolated, you can think about as a lower bound. Okay, so this is a lower bound that this paper provides in the sense of if you add like capital and sticky wages and other forms, then the inflation effects will be even larger than the ones that we emphasize. Okay, so that's basically the bottom line of this paper. Are there any questions from you? Are you sick and tired of this paper now? You cannot stand the paper anymore, or do you think like, oh yeah, I mean, that's cool. Now, of course, this paper also has shortcomings, right? And let's try to, and I want to hear your words on this. Given everything that we discussed, let's think a little bit about, for maybe 5 minutes, what do you think are, where is upside potential on this paper? Okay? It's not called shortcomings, but where do you think this paper has upside potential? So if you were to redo this analysis by yourself, or after everything that we discussed, what are the things that you think this paper is lacking, for instance, or could improve? Okay? So, let's just have a little bit of bullet points on where is upside potential for this paper, or the analysis. Who wants to go first? What are your thoughts? When you think about everything we did, where would you place, maybe a better and refined analysis would be good to do in that or that direction, or dimension?
I think it's
the what?
Parameter, because
The parameters?
the probability from input from exists
Oh, I
is
see.
constant.
So do you mean the var phi parameter on the
Yeah.
on the tax?
Yeah.
Okay. So how that is identified and where does this come from?
I mean, it can change over time.
Oh, I
The
see.
probability-
So you're saying this is a constant parameter in the model. You could think about there could be time variation in some of the parameters. Good point. Yeah, let's write this down. Right. So there's like there could be time variation in some of the parameters of the model parameters, right? So then this goes back to the idea that they are doing 75-year forecasts. You could think that in those 75 years, some of the parameters may have different values. This could be, absolutely. That's okay, any other thoughts? Any other thoughts?
I mean, like just now, like you already like gone through a lot of things that we can add up on the green inflation side.
Yeah.
So I think it's also potential upside. But like for me personally, what I feel is like when I reading this whole paper, it seemed like the whole burden about this kind of like supporting climate change for the central bank, and sometimes it's like I think a lot of things about the carbon taxes, right? It's actually because we mentioned about the tax rate, is some of the scope should be like is outreach beyond the central bank responsibility alone, and it kind of like it's not really like effective here.
I'm not quite sure. I mean, it's a good thought, but let's talk about this. So the carbon tax is not imposed by the central bank here.
Yes.
It's imposed by, say, the government, right?
Yes.
So in this model, it's the government who imposes the carbon tax. I see. And you're saying the analysis here is focused on what can the central bank do, conditional on whatever carbon tax we have. What are the options for the central bank? And you're saying you could extend the analysis on the carbon tax and refine what better carbon tax options do we have, or other means of climate policies than carbon tax. Is that what you're thinking? Good point. I like that. Okay. So you could actually extend the climate mitigation policies analysis beyond carbon taxes only. Absolutely. There's other ways of climate mitigation policies. You could set incentives to invest in green energy, right? Something that we don't have here. Right? You could pay subsidies to firms who invest and stuff like that. So there's certainly potential there. Okay. So you could extend the analysis. To a broader set of mitigation policies. So beyond taxes, beyond carbon taxes. That would be good, right? Absolutely.
And so far in here, it's still like a closed economy.
Here we go. Okay? So that's something, we touched up on this, but this is a closed world economy. And you could certainly think in splitting this up into, maybe a two-country analysis or like a small open economy analysis, where there is possibly also trade. So either multi-country or multi-sectoral setups, right? You could also think about it, we have one production sector. You could think about splitting this into there's a green energy sector and then there's a brown energy sector, right? And how in a country with green and brown energy sectors, the interaction, operates. So the brown energy firms, they are likely going to die at some point, and the green energy, and when is that going to happen, and so forth. So, one upside potential is to move away from the global closed economy framework. Okay? So this is the global closed economy framework, right? And move away from that to go into a multi-country setup. Okay. You could think about a multi-country setup, which which doesn't need to be overly complicated. You don't need to go into full-blown two-country setup, but we just outline, you could have a small open economy that has some trade, but takes a lot of things from the world economy as given, like Vietnam. But that would allow you to think a little more carefully about the contribution of Vietnam to, say, climate change. And then you can also think about the multi-sector setup, like brown versus green energy sectors and so forth. So a multi-sector setup. So that would be also a very interesting thing. Certainly worthwhile to see. Okay. Any other thoughts that you may have?
Implications for fiscal policy as well.
I see.
Mix of just monetary policy.
Yeah, exactly. More options for fiscal policy. And maybe let's develop this a little more. Let's develop this also a little more here. So there could be, fiscal policy could be, extended. Fiscal policy. And what often is sort of say discussed in frameworks like these is to highlight further the implications of inequality for climate change and what fiscal policy could do to help the effects of inequality. So what we know is that very poor people are affected to a much harder degree than very rich people, right, by climate change. The model abstracts from that. I mean, it has a flavor of it with the employed and unemployed people. There is something, but that analysis isn't really borne out in detail. Let's put it this way. So one extension could be a more a more detailed understanding of inequality implications of climate policy. Okay, so focus more on that. So this could be inequality implications of climate change. Of climate change. And then related to that, going back to fiscal policy and redistribution policies. Right? That could be very interesting to think about. Like if you put more rich and poor people into your analysis at the forefront, and think about more like who are the winners, who are the losers from climate change, and then think about what fiscal policy measures could be taken up to illustrate, how this economy could fare better in terms of inequality and so forth. Okay. Certainly a very important and worthwhile idea. I'm looking for maybe one more, and then we're going to call it a day for this paper. And can you think of another thing, so to say? Maybe let me give you a hint on this. So greenflation is coming in this model because of extra demand by firms. And we've seen that greenflation can be substantial. Can you think about a model setup where greenflation may be less inflationary? What does the model abstract from explicitly? I mean, it has a flavor of it again, but it could be developed further. Think about explicit technological progress in green transition spending. Right? I mean, the model has a flavor like this, that mitigation because of this theta 1t parameter, right, falling over time. There is a flavor of that, so don't get me wrong. Let's go back here when we set up the model, right? When we set up this this model in terms of the is it here? No, I don't know. There. When we set up this model, right? So this is the spending on abatement, and this thing is falling over time in a deterministic trend. Okay? So the cost of abatement falls. But you could think about extending this model along the lines of, say, there is a particular productivity process for abatement spending. Okay, so that abatement spending can become more cost efficient faster than this deterministic decline. Could be, for instance, if the government subsidizes R&D in green energy, and all of a sudden you have firms that do heavy research and development in abatement, so to say, technologies that could, so to say, have these costs deteriorating faster temporarily, and which of course would then dampen the greenflation effects. Okay? So long story short, any like an extension of the model to have an explicit green R&D sector, that would actually, think about technological advancements that could then also spill over to the rest of the economy. Would be an extension of the model that would be able to address, all the climate-flation effects, the greenflation effects really that large, and open up the possibility for such an analysis. Of course, that will be a more substantial change to the model, like with all the changes that we are considering, but certainly something that is worthwhile maybe pursuing. So you could have something like, R&D and technology in green or in abatement. Okay? So that there would be like maybe a sustained extra force of growth in this economy coming from the abatement spending, like the solar panels that would then be widespreadly used in the economy, and so forth and so forth. Just another thought, and then of course there's a million other things that can happen. Great.
I have a question.
Yeah.
So with the original model for this climate change, we found the final points that we say about R&D and technology growth.
Yeah.
Is it so in the original abatement cost is kind of constant. It's growth. The efficiency change, but because there's no improvement in technology, so the change, the growth is the same. And also, maybe I think it's made because we also have technology shock, but technology shock in the state in the model. In exogenous shock, just mentioned about the labor. The labor that if technology shock happen, the cost will decrease.
Yeah.
Yeah.
That's right.
Yeah.
That's-
So that is this is true. That is the thing that we can separate the technology shock in abatement cost. In green in technology and technology, but in the general technology, but just improve the productivity of human capital.
So you're touching up on a decomposition essentially. If we go back here, sorry, I want to show you. So I think what you have in mind, Lynn, is right, when we did the Phillips curve decomposition, we reminded ourselves that marginal cost in this economy is a wage, it's climate-flation, and it's greenflation. And by extending this model to say have abatement-specific productivity, right? It's showing up here a little bit, but you could bring this to a different level, to a stronger force. That just like with other technology shocks, this would actually be a downforce on inflation, on marginal costs. That if you figure out how to produce a fusion reactor at small scale or hydrogen cars, now that could be actually a reduction in marginal costs, even though firms are spending. But if there are enough firms spending on abatement, it could trigger so much R&D that in the end, per unit, you're going to produce cheaper. Now, to be fair to the authors, and I think it's very important, it's in part captured here, but maybe that effect is not yet strong enough to allow for the possibility that this could actually be a force down here, right? So in other words, what happens right now is that this thing is falling, but abatement is going up by more than what this thing is falling. And you could think about specifications that investment in green technology either can actually spill over to as what you seem to be saying to the regular labor sector as well. So that would benefit from better productivity there as well. So all I'm trying to say, this is not a fully fledged, clear-cut idea. All I'm trying to say is that you could think, and there are papers in the literature of explicit R&D in the green sector, and that has beneficial spillover effects to the rest of the economy, and thereby reduces the inflationary effects, right? So go back to what we learned in the New Keynesian model, right? After, say, a technology shock, right? In the standard New Keynesian model, after a positive technology shock, we learned that inflation does fall. Okay. And you know that's where this green energy R&D could come in. If you model that in a different way, you could end up with that green energy technology improvements could actually bring a downforce at inflation, just like an improvement in technology in the overall production sector. So that's where, so to say, this last bullet is, and it depends on the details, like what Lynn was saying, on which sector benefits from that and how does this work. All right, that's it. Okay. Let's call it a day on the macro climate model, and I think we've come very far with it. Okay. What we're going to do today is we're going to start now. We're going to start with the monetary fiscal part, and we're going to have 3.5 days left. And then we're going to start with that. Okay? And where are we going to, where's the material? Again, I told you yesterday you had this, self-study session. Everybody has read this paper. And what I'm going to do next is I'm going to cover this today, and then tomorrow and on Thursday we're going to be with and without. And most likely on Friday, we will have another coding session. So on Friday, we will do some computer codes, and we will write computer codes pertaining to this. So we have a day and a little more on the theory, and then we do computer code. Good. That's the plan for today. Now I have to figure out a way. Let me see. Where is this? I have to find the folder, my slides. There we go. Yeah, perfect. I want to share. There we go. Some good notes. Very good. And then next is going to be mine. So there. Share. There we go. Okay. I think we're in business. Okay. So this is the first slide deck that is serving the purpose of introducing us to this thing. So this is lecture 5, the monetary fiscal, the motivation, and then this is the lecture slide 6. But we're going to go 5 next. So what's the motivation for why are we covering this in class? So first of all, the paper that you read is a paper published in the Quarterly Journal of Economics. It's one of our prime top outlets in the profession. And it discusses, or it develops an analysis on when are government deficits inflationary. So when the government runs a deficit or increases the government debt, when do we see more or less inflation? Under which conditions? That's the whole idea of the paper. And it takes the position, as you have read the paper, it says, or finds, there are times when more government debt can really increase inflation. And then there are other times when government debt doesn't seem to have any effect on inflation. And the paper offers an explanation for that. That's basically what this paper offers. So let's set a little bit the stage, and let's review some data first. Let's review some data, and after we've been reviewing data, we will come and produce a model, develop a model that can account for the data. Exactly the standard macro workflow that we have in macro. Examine data, build a model, explain the data. All right. So what is this? This time series here that we see on my screen is U.S. government debt. So this is U.S. government debt. It's a time series from the 1960 going all the way to 2025. And what you see is that this is in millions of US dollars, okay? And the latest observation is 36 million US dollars. So this is 36 trillion US dollars. So what you see is over the last 60 or so years, 65 years, the nominal value of US government debt has increased almost all the time. There's very few times when it fell a little bit. But then most lately, for instance, in the COVID pandemic, you see big jumps, right? So this is, in the COVID pandemic in 2020, you see that the US government debt went from 23 trillion to, within a couple of months, to 26 trillion. So 3 trillion. That's almost the size of German GDP. That was the increase in government debt in the US. So you see that government debt keeps on rising in the United States. Now, this is in nominal terms, in trillions of US dollars. You can express this also in terms of, you can express this also as a fraction of GDP. By the way, let me ask you, have you ever worked with Fred? Do you know what Fred is? Yeah? Okay, good. So you go to this website and you can get all the data and plot it, and these are just taken from Fred. Okay, good. Okay? So you can take this nominal debt time series and you divide this by GDP. So this is US debt divided by GDP. So this is US government debt divided by GDP. So this is nominal debt divided by nominal GDP. So you get the debt to GDP ratio. That's what this is. And you see that the debt to GDP ratio was about 40%, and it fell for almost 2 decades. It fell, and then it's rising for another 2 decades. It's kind of stable, and then you see these discrete jumps. So this is the financial crisis when U.S. debt to GDP increased. Now, of course, it increases for 2 reasons: the nominal value of debt increases and GDP falling. Both of them pushes this up. And then you see the COVID response, where the debt to GDP ratio increased very sharply, as well in those episodes. So we have these observations that the U.S. debt to GDP ratio, goes up and down, and in general the level of debt keeps increasing. Now that's not a big problem if GDP keeps rising, but when there are big, recessions, you can see that the debt to GDP ratio may take different turns and different directions. All right. So what does this paper now try to do? It tries to provide a link of this debt to GDP ratio, or the deficits, to this inflation time series. So this is U.S. inflation. Okay, this is U.S. inflation as measured by the consumer price index. Okay, so this is the consumer price index. And what you see is we had in the 60s and 70s, we had these big inflation records, right? Inflation went to like 12 and 15%. And then we had a period of time that many people call the Great Moderation, where inflation was relatively tranquil. And it was like between maybe 2 and 4% was fluctuating, basically. Even in the biggest recession in the last 80 years, we've seen inflation, being moderate in its volatility. And then only very lately, like in the inflation surge period, we see inflation numbers in the order of 8% measured by the CPI. What the paper asks, or the point the paper tries to make is, can we think about that some of these inflation is actually attributable to the run-up in government debt? Is there like a systematic relationship between the two? So when the government spends more, it may come out inflationary. Or when the government borrows or you know, but there is no big systematic relationship. So if you take this and you superimpose it on this, you will see quite a low correlation. Actually, a little negative correlation, right? We'll say that when inflation, the debt to GDP ratio has a trend, goes up, inflation has this downward trend, there will actually be a negative correlation. So the theory is more elegant and more detailed in how to think about the relationship between inflation and the debt to GDP. That's the whole idea. And we want to understand what does the deficit actually mean and what can it create in terms of inflation under which conditions. And one thing that's going to be crucial is the interaction between the monetary authority, the central bank, and the fiscal authority, the government. And hence that's the reason why, and this is called in the schedule, monetary fiscal interaction, because we're going to learn the ultimate outcome for inflation depends on, you know, the power that the central bank has over the government or the other way around. That's going to be an important, you know, takeaway later on. Okay. Now, a year ago, the U.S. President Trump put in a new bill that is called the Big Beautiful Bill. Have you heard about the Big Beautiful Bill? Like 1 year ago, the U.S. government put in the so-called Big Beautiful Bill. So the big. I cannot know here. Oh, I see it. So this is the Big Beautiful Bill. So a year ago, the U.S. government, I mean Trump and Republicans, put in a bill, meaning what do they propose there? They proposed big tax cuts, and right, they proposed tax cuts to continue. They were about to elapse the taxes in terms of low taxes, and taxes were supposed to go up, and they extended the duration indefinitely for these taxes to not go up but to stay low. So implicitly, it's a tax cut going forward. Okay? And they also enacted increases in spending. Long story short, there is the so-called CBO, that's the Congressional Budget Office. It's a body of the U.S. Congress that has estimated that the Big Beautiful Bill will amount to about $2.4 trillion extra in debt. So the debt that will arise from the tax cut will amount to about $2.4 trillion. That's basically how the way we think about this. Now, in terms of, and then of course there's a discussion. 4 weeks later in the Fortune article, magazine, then they actually have estimated, oh no, it's going to be 3 trillion. So not 2.4, it's in the order of 3 trillion. That what this Big Beautiful Bill is going to cost. Okay, and then it finally was approved, the Big Beautiful Bill, that it was passed in the House and passed in the Senate, and it was actually put into policy. And I'm giving you these articles here as a basic motivation of, well, there is actual recent policy making that asks, or you can think about, well, if this bill is not an if, this bill is put into place, if it really adds another 3 trillion, then you can think about this thing is going to keep going up, at the latest observations here. So this thing is going to keep growing to 40 trillion, right? to 40 trillion. From about 36 to 40 trillion. So it's going to add more to the U.S. government debt. And it's going to add more to the debt to GDP ratio as well. So in other words, the Big Beautiful Bill, right now the U.S. debt to GDP ratio stands at 120%. So you need 1.2 years of U.S. income to repay all the debt. That's how 120% debt to GDP ratio is. And if you include the Big Beautiful Bill, it's going to keep on going up. It's going to be even higher. And there's a lot of economists in academia, in policy making, journalists, businessmen and women, they're very concerned about these very high levels of government debt. And whether that's going to result in problems for the U.S. economy, especially for the government, but also in terms of inflation. People are talking about, the only way to get rid of this is to inflate the debt away. And what we're going to learn in this paper is exactly how to think about, that interaction between high debt, monetary policy making, and fiscal policy making. That's the basic Now, the ballooning of government debt isn't just a phenomenon in the US, it's a phenomenon in many countries around the globe. And just since last year, for instance, we have a new government in Germany. And there is a new government, and that actually did something that many Germans are concerned about. Namely, they changed the constitution to actually allow an additional amount of borrowing of 800 billion euros by the German government in the next 5 years. So there was this big this initiative that the so-called debt reform plan, and it was passed in the lower and in the upper house of parliament. And basically, what this meant is that in Germany, the total borrowing that this change of the constitution allows is about 850 billion euros. Some of it is earmarked for defense spending, but some of it is earmarked for infrastructure spending. But it is a huge increase in the German level of debt going forward that we are going to see. In the budget that the German government has per year is about 400 to 500 billion. So this is a multiple of the annual budget in terms of extra spending. Okay? So we have a similar problem, not a similar problem. Germany has a lower debt to GDP ratio to begin with, but ballooning government debt, big deficits, and the repercussions thereof are something that's also hotly debated in Europe. Okay? It's not, and this is not just Germany. If you go to other countries, we have similar features, similar problems elsewhere. Great. So that's the motivation for why we are working with this paper. It's a very recent and a very pressing topic, and we have top papers that help us thinking about what may happen going forward. And that brings me to this paper by this paper by Melosi and Faccini and Bianchi. Okay, so we're going to enter now the second topic in this paper, in this work. And I have decided to pursue the same strategy as with the Hermandel, Sarhuk, and Smets climate paper. I want you to be able to first read the top journal article. We all have done that. That's a QJE paper. And I want us to also understand how do the authors present their work to the community. What are they thinking? And I don't want you to subject you to my filter. I could have prepared slides and my own interpretation of their work. I didn't want to do that because I want us to go through how they are pitching it. So you learn how to pitch a research paper. Okay. So, and then we can have a debate, as with the macroclimate, on some of the great things this paper has, but then also some of the shortcomings that paper has. So this is a paper that's called The Fiscal Theory of Persistent Inflation. It's by Francesco Bianchi, who is at Johns Hopkins in the US, and then there's Renato Faccini from the research department of the Danish Central Bank, and then there is Leonardo Melosi. He used to be at the Federal Reserve Bank of Chicago, but he is now at the EY in Florence. So he's back in Europe at the European University Institute in Florence. And they've written this wonderful paper that we're going to study. What is the key idea of the paper? This key idea of the paper is to come up with a new class of general equilibrium model that has one new feature, which is what they call partially unfunded government debt. That is, if you have to describe this paper, then that's basically the description of what that paper is. So, what is unfunded government debt? Well, suppose the Vietnamese government is cutting taxes to the people in Vietnam. Okay? It's reducing, say, the VAT tax. So how, so tomorrow you go and you wake up and you see in all the stores, instead of 8% VAT tax, you're paying 0% VAT tax. How is the government going to finance that? Every time the government cuts a tax, it needs to finance it. Why is that? Well, there's expenditures in the Vietnamese economy by the government for schooling, for education, and social security, So So the government has a level of expenditures to spend, and they typically use tax revenues to finance the spending, okay, of universities and schools and so forth. Now when the government cuts the tax rates, there's no revenue, right, to finance these expenditures. So what does the government then do when it cuts taxes? It typically goes and borrows the money. So when the government cuts a tax, it could, it keeps the spending the same, right? Then it somehow needs to, make up for that difference between the revenues it had before the tax cut and the revenues it has after the tax cut. And that missing part of revenues, the government typically goes to the financial markets and borrows money. So that's what typically happens when you have changes in fiscal policy, a cut in taxes, you're going to have more debt. All right, so that's the first thing. We have a government that has more debt. Now, what's going to happen with this debt? Who's going to lend the government money? What is a financial market that lends the government money? Well, it's guys like you, or guys like me. A guy like me, I'm going to have some savings, and I want to, invest my savings. I can invest this in the stock market, but I also can invest this in government bonds. So there's going to be investors that are going to come to the, where the government is going to go to these investors and say, look, I need to borrow 1 trillion Vietnamese dong to finance the tax cut. And I offer you, if you give me 1 trillion Vietnamese dong, if you want to invest it, I offer you an interest rate of 5%, say, per year on the money you're lending. So the Vietnamese government goes and lends money to finance the tax cut, and investors now hold a piece of paper in their hands that says, the Vietnamese government is owing you 1 trillion Vietnamese dong at an interest rate of 5%, and it's promising you to pay back that in some time in the future. Say in 10 years, this paper will be returned to the government, and the government will pay the investor these 10 trillion plus interest. That's the typical debt financing. Okay, that's the typical, when you have, a tax cut, you're going to end up with more government debt. And the same story goes if you are, increase your defense spending, and you don't want to touch taxes. When you increase your any spending by the government, and you keep taxes constant, the deficit needs to be financed by more debt. So you always need to find somebody who's willing to lend money to you. So there's no problem so far. The problem is going to come in 10 years when the investor says to the government, well, I have this paper, that's a bond, telling me in 10 years the government is going to pay my money back. That's the time when the problem is going to start. Because in 10 years, right, the government needs to pay back the bond to the investor, so there needs to be money coming from the government to the investor. Where does the government get that money from? So, in the standard idea is that in 10 years, the government needs to raise money somewhere in the economy to pay back the debt. And a funded government debt means you have a funding source, meaning that you will raise taxes, say, in the future to pay back the debt. That is funded government debt. Okay? So any tax reform that you do today is funded and backed by future tax changes. Or if you spend more today, funded government debt that you need to, going to spend more today, you're going to raise debt, but there's funding in 10 years, you're going to raise this and that tax in order to pay back the debt that you have. That's what's called funded government debt. These authors consider an interesting case when the government borrows money but hasn't written any laws on how to pay back the money. That's what they call unfunded government debt. So there is no backup plan for raising taxes in the future. Or, and that's where the partially comes in, the partially means that the government only say has a plan for 50% of the loan. So suppose, the government in Vietnam wants to borrow 1 trillion and only has a plan to how to repay 500 billion Vietnamese dong. So only 50% of the debt is planned to be covered by higher taxes. Okay, that's the idea. Okay, so the partially unfunded idea is that there is some amount of government debt that is not backed by future tax revenues or by future surpluses by the government. That's the key idea. If you understand that, you understand a lot of the economics of this paper in terms of what can happen in a situation like that. Okay. So there is the idea that there is a part of the government debt that is outstanding and that's unfunded. And then the question is, how much inflationary pressure does that deliver? In a setting when the central bank is weak or strong. So that's the idea. So that's what the paper studies. Under which conditions, when you have to, when the debt is high, under which condition does it, generate inflation? And what they show is, they show debt stability, sort of stable government debt, is achieved by a mix of adjustments in fiscal and inflation. So the big bottom line, the big takeaway from this paper is that if, say, the Vietnamese government only has a plan to repay 50% of the debt, then inflation needs to do the rest. That's the idea. And the idea is, of course, the following, right? So suppose you're borrowing 1 trillion, and in 10 years you're intending to pay back with planned expenditures 500 billion. Well, the other 500 billion need to be eaten away by inflation. Inflation is eroding the real purchasing power of your money, right? So the 500 billion today, over 10 years, with 10% inflation, the real value of those 500 billion is going to be much lower. Right? So you're inflating away a level of government debt, as we see. And what they show is that with partially unfunded debt, you don't need to go to default. You do some fiscal adjustment, and you do have some inflation in your economy as an outcome. And that will lead to a stable debt and output dynamics. So we're going to learn this more by heart using a very simple model. But then they go on further. They go on to study what happens if you toss in nominal rigidities into this model. Okay? So when you are bringing in sticky prices, when inflation is evolving slowly over time, okay? Then what they show is that the inflation can go up persistently over time. So rather than inflation needing to jump like in Argentina or in Venezuela, with sticky prices you're going to have inflation being persistently higher. So that is the reason why they call this a fiscal theory of persistent inflation. Okay. Now, importantly, they emphasize you don't need to rewrite your entire model, suit that you use to analyze the economy. It's an add-on to existing models. So this is an add-on to the standard Keynesian model, if you like. Okay. Standard business cycle shocks, like for instance, technology shocks, they propagate exactly the same as before. The transmission of business cycle shocks, like demand shocks, cost push shocks, the transmission of those are completely the same as before. It's just that fiscal dimension is going to have different implications, as we will see. Okay. So then, this paper is really rich, and to be honest, there's a chance that we may not be able to go through all the results of the paper, which is not a big deal. I want to make sure you understand the key ideas and the key results. Okay? And then at some point, maybe on Thursday or so, or Friday, I'm going to tell you this is the end of this kind of course, and the rest is not relevant for the exam. Okay? So if we're not able to cover some of the slides, then they are not going to be relevant for the exam. Okay? That's the basic game plan. Okay? But the paper has a rich set of analysis. Among others, it has an empirical analysis. They're estimating the model. Similar techniques than the macro climate model was estimated. Okay? So they have data, and they ask the model to explain the data, and that way they estimate parameters. A very similar, methodological setup in terms of estimating the model. And then they have a so-called TANK model. What does TANK stand for? Great. Wanted to know whether you read the paper. Okay, so that's perfect. So this is a two-agent New Keynesian NK model. Okay, perfect. So this is a two-agent New Keynesian model. So they have poor people and rich people. They have poor hand-to-mouth people and rich people that are Ricardian, smoothing consumption over long periods of time. So they have these Smets and Wouters standard frictions. So this goes back to like Smets and Wouters, right? 2007 AER, right? These standard features in that. But then they have these cool new things on these unfunded fiscal shocks. I don't know whether it's cool, but they have these unfunded shocks that we can use and think. So the idea is that after we studied this, what you can do with this is you can evaluate policymaker proposals. Say, look, Trump, he has this big, beautiful bill, an increase in debt by 3 trillion, but the law only funds 1 trillion. You can put that information into a model and calculate what is likely going to happen with inflation with this configuration, and what's going to happen with output. And that's basically what this analysis is going to allow us. And they are very realistic in the sense of allowing for hand-to-mouth consumers and so forth. They have cost-push shocks. You see that every investment that we did in this course, is paying a really juicy rate of return. When we on last Tuesday, when I introduced you to the idea of cost-push shocks in the New Keynesian model, some of you may say, it's interesting, but where does this lead us? Well, it was an investment that pays off the juicy rate of return because we needed these cost-push shocks to understand, in part, the macro climate model, right? There was this dedicated cost-push shock, but there was also this, climate trade-off for the monetary policy maker that looks like a cost-push shock. And here we go. We have another paper that uses these cost-push shocks. So as I told you, they are used in a very widespread way to think about this. And they are pitching this at the end that, how much this unfunded fiscal shocks matter. It's a quantitative exercise. Okay? So we need to estimate this model. So then what they before, so what we're going to do, I want to get here, I want to get there today. So let's, and this is really just giving you an outline. What they then do is they say, let me look at this US post-war inflation rate. So let me take a look at that rate of inflation. There we go. Okay. So they're staring at that rate of inflation and then asking, what was driving this rate of inflation? What were the driving forces? Why did inflation go up and down and so forth? And they're basically saying, well, US inflation, you can think about this, was driven by a lot of unfunded fiscal expansions, unfunded government debt. Okay? So they're saying, you think about the 60s and 70s, that was, by US standards, the buildup of the welfare state in the US. Okay? That was a lot of social transfers going to households. And those transfers were backed by future tax increases. Okay? Lots of transfers shuffled to households, and they were not backed by future tax increases. So that actually is through the lens of their analysis explains that big run-up in inflation. Now, whether this is so this is of course a different perspective on the sources of the inflation run-up than other models. Some say no, this was oil prices and so forth, but this paper says it was unfunded fiscal liabilities. Okay. Then there was a relative phase of tranquil, right? The 90s were tranquil. There was not so much action there, but then there were two other massive fiscal stimuli in the United States in the recent years, right? One massive fiscal stimulus was in March 2020, and the other one was in March 2021, both related to the to the post-COVID recession, okay, or to COVID, the epidemic, and to the COVID recession. And they are showing, or they are through the lens of their analysis, is that this first stimulus was backed by future tax raises, right, and didn't lead to much inflation, but that second one produced a lot of extra inflation, through the lens of their analysis. So the first stimulus was put together by Trump, okay? The second stimulus was put together by Biden. So you can think about the Trump according to their analysis. And again, I'm a consumer. I don't side with the authors, yes or no, or I'm not supporting this or not. But just reading what they're trying to, what their model implies is that the first stimulus, when the epidemic hit and people got subsistence transfers, that act, that tax change or transfer change didn't lead to lots of extra inflation because it was backed by future tax changes. Then the American Rescue Pact, that's what ARPA means. So ARPA means American Rescue Package Act. By contrast, this American Rescue Package Act didn't have any fiscal backing. And there was a lot of extra spending, and that extra spending, so to say, didn't work back by future tax increases. And they used a model to show that that has led to a big run-up in inflation. So their view of the world is this run-up in inflation that we observed at the end of the sample was due to the big government deficit run in the US under the Biden administration. That's basically the model. And what we're going to do tomorrow is we are going to sharpening our knives and going through and slice this model, understanding every little bit in piece how you can arrive at such a conclusion. And then we're also going to have a discussion on what are maybe some of the things that the model overemphasizes or underemphasizes, and are there alternative ways to think about what drove the run-up in inflation. We're going to have a detailed academic discussion tomorrow. Are there any questions on this? So I hope this sets the stage for an exciting day tomorrow. So tomorrow we're going to be getting through this model and understanding the important bits and pieces and the intuition. So tomorrow is going to be a very important day. Okay? And then we'll take it from there, applying this model and so forth. Okay. Thanks everyone. I'm looking forward to seeing you tomorrow at 9:15 again. Great, thank you. Have a good one. Thank you.